Greetings, geometry students. This is Mr. Heeren, and we are beginning our exploration into Unit 2, talking about parallel lines and kind of everything that happens with those. I hope that Unit 1 and the logic unit went well for you. As you'll come to find out, being very, very particular with your language in geometry is a big piece. Due to the arbitrary nature of English, where it's very easy to misinterpret things. In math, especially in geometry, we have to be very, very picky about how we say things so that they convey what we want to say. So I will give you a perfect example is this, parallel lines. Okay, most people would just simply say, oh, parallel lines, lines that never touch. And that's only partially correct. Okay, that's only partially correct. If you consider parallel lines, what they actually are two lines that are on the same plane and what are called equidistant apart. Okay, they are on the same plane and they are equidistant apart. So equidistant is a fancy math way of saying they are going to be equal distance the entire time. Okay, so if I measure this, if this is just, length A, then it's the length A all the way. That never changes. Okay, now you're saying, Mr. Heeren, that's exactly what it means when it says they never touch. Well, technically, to a point, yes, but this on the same plane is very important because if I look and I have two planes and I have a line on this plane, then I have a line on this plane, those two lines will never touch. Those two lines will never touch, okay? But they are not parallel. And we'll talk a little bit more about what types of lines those are in a moment. But I just want to make sure that you are very, very picky about your language when you start conveying your ideas here. So let's look. Parallel lines, we just kind of defined it. So parallel lines, number one, they are going to be what's called coplanar. Remember, on the same plane. Okay, and they are going to be equidistant apart. Okay, and if you want to say never touch, that's fine, but you have to realize that there's other types of lines that never touch as well, but they're not necessarily parallel. Okay, so when we talk about parallel lines, we're talking about same plane and equidistant apart. So let's talk a little bit about that type of line. These are called skew. Okay, they will never touch. All right, they will never touch as well, but they are not coplanar. And they are not equidistant apart. All right, so it's like here, line M in plane R and line N in plane P, they're skew. They're never going to touch. So I mean, the distance from here to here is different from the distance to here to here. Okay, different distances. Okay, and oftentimes skew lines are on parallel planes. And parallel planes are exactly what they sound like. They are planes that are going to be equidistant apart. And they are going to be equidistant apart, and they are going to be, they are also never going to touch. And it's on parallel planes that you often find skew lines. Okay, so if we consider parallel planes, it's kind of like this. They're always going to be same distance apart. Okay? Okay. So now let's focus more on what happens with parallel lines. Okay. So anytime you have two parallel lines, okay, and we're saying that S and V are parallel, and this is often the symbol that they'll use, just two little parallel lines. That's the way that you write parallel. So we're saying that line S is parallel. Oh, I can't seem to spell right now. Is parallel to line V. Okay, so these two lines are parallel, and sometimes you'll see a symbol of two arrows like that. That's an indication that those two lines are going to be parallel. Now, T is what you're called a transversal. Okay, it's simply a line that intersects two parallel lines. Okay, that's all a transversal is. Now, when that happens, as you notice, eight angles get created. Okay, so then they're numbered 1, 2, 3, 4, 5, 6, 7, 8. Okay, these are all angles that are created when you have two parallel lines and a transversal, a line that intersects the two lines. So the two ways we distinguish the angles are our interior and exterior. So interior, kind of like interior angle, is going to be inside the lines, the parallel lines. So we're looking at 3, 4, 5, and 6. So the exterior then is going to be the others. We're going to go outside the lines. And when I say lines, I'm referring to S and V here. Okay, I'm referring to those. I'm not referring to T. I'm referring to the parallel lines. So my exterior angles are going to be 1, 2, 7, and 8. Okay, get comfortable with interior and exterior because that's going to come back and play a role here. So make sure you can distinguish between those two. So now, when you have parallel lines here, so once again, we have our parallel lines, S and V. Okay, so we have S parallel to V. All right, T is your transversal. Okay, so now we have what we call consecutive interior angles. Okay, so consecutive interior angles, I'll give you the quick example. So consecutive interior angles are going to be 4 and 5 and 3 and 6. Okay, often sometimes called same side interior angles. Okay, those are often also called same side interior angles. Okay, and these are going to be the only ones that are supplementary. Supplementary is a word that came up in Unit 1. And all that means is that it adds up to 180 degrees. So that is what you do. Okay, so these two together are going to add up to 180, 4 and 5. 3 and 6 are going to add up together to 180 as well. So now alternate interior angles are a little bit different than consecutive. Alternate interior would be 3 and 5. And 4 and 6. Okay, alternate just means opposite sides of the transversal. Okay, so they're just opposite sides of the transversal. Still interior, you're still inside. Okay, and what ends up happening here is 3 is congruent to 5, and 4 is congruent to 6. Remember, congruence just means it has the same measure, okay? That's all it means. So I'm going to rewrite that a little cleaner. So angle 3 is congruent to angle 5. Alternate exterior, same kind of thing, okay, opposite side of the transversal. Exterior means now that I'm outside the lines, okay? So I'm looking at like angle 1 and 7 and angle 2 and 8. Those would be alternate exterior angles, okay? So, and those are going to be outside the lines. And once again, those are going to be congruent to each other. And this is all going to come into play here in a little bit. So you got to remember, the only situation where it's not congruent is going to be supplementary. So everything else is going to be congruent. So that's a good way to remember it. Then lastly, corresponding just means angles in same location. Okay, that's all it means. Angles in the same location. So examples are 1 and 5. So if you notice, 1 is in the same location as 5 relatively, okay? So they're both like above and to the left of the transversal. So you have 2 and 6, okay, 3 and 7, and 4 and 8. Okay, so there's four pairs there, and they are going to be congruent. So angle 1 congruent to angle 5, angle 3 congruent to angle 7, angle 2 congruent to angle 6, and angle 4 congruent to angle 8. Okay, but it's very important you be able to recognize these pairs, these orders of angles. Okay, so it's very important that you be able to recognize that. Okay. So perpendicular lines. We've spoken a little bit about this before. This is something you've probably seen before. Perpendicular. In order to be perpendicular, you have to be very, very specific. Perpendicular lines form to meet a 90-degree angle, often denoted by like a little box like that. So this vertical angles, this is kind of a review. This is a review from I think 1.5 or 1.4. When you have the situation 1 and 3, 2 and 4 vertical angles, those are always going to be congruent. Okay, those are always going to be congruent. All right, the angle 1 is going to be congruent to angle 3, angle 2 congruent to angle 4. And if you don't believe me, you can get out your protractor and cross some lines and measure it and see that it's correct. See that you're going to get the same measure for both of them. Linear pair, it's another kind of throwback to Unit 1, and that means that they're going to add up to 180 degrees. Okay, so you have two angles that are going to add up to 180 degrees. So two angles form a linear pair. If they form a line, and remember, a line is going to be 180 degrees. So in our situation here, 1 and 2, together they make a line. 2 and 3, together they make a line. 3 and 4, together they make a line. 4 and 1, together they make a line. So these are things that we talked about before, but it's good to review them because they're gonna be used in here. So if you look, so here we have two parallel lines. So this line and this line are parallel. That makes this line, okay, that makes this line a transversal. Okay, so now we're using vertical angles and linear pairs to kind of fill in the measures. Okay, so that makes this 62. That makes this 118. All I did was vertical angle stuff. Okay, so then we realized that, these two make a line. So 118 plus, x equals 62, or not 62, gave away the answer there, apologies. Should be 180, but when you subtract 118, you're going to get 62 for your answer. So this is going to be 62. That makes this 62. And if I do something similar down here, 62 plus y equals 180. Well, I'm going to get 118. Now look what has transpired here. Look at what's happened. Just using linear pair of vertical angles. Notice you have angles that kind of match up that are equal. Okay, you also have like angles that go across that are equal. Okay, that's not a coincidence. So that will happen every single time. So if we consider here, just doing vertical angle stuff, that's 97, that's 83. Then if we do linear pair work, so you go 180 minus 97 is going to equal 83. Here and here. And down here, that's going to be 97 and 97. So please note that that's going to be look at this situation. 97, 97, 97, 97, 83, 83, 83, 83. Okay, so from there, we can kind of come up with some things that we notice, come up with some rules that that happen when two lines cross each other, when two parallel lines cross each other, and they're cut by a transversal. So, in two parallel lines cut by a transversal, then alternate interior angles. So 125, 125. This would be 55 then, and 55, 55, and 55. So if we look at alternate interior angles, we're looking these two and these two. And notice that they're going to be congruent. So then if two parallel lines are cut by a transversal, alternate exterior angles. Okay, so we have alternate exterior angles. So I'm looking at this one and this one, and this one and this one. Okay, so I'm going here, and I'm going here. Those are also going to be congruent. Now this one gets a little tricky, so just stay with me. Corresponding, again, we have two parallel lines cut by a transversal. The corresponding angles are let's see, so 125, 125, 55 and 55, 55 and 55, 125, 125. Okay, remember, same location. That's what we're looking at. Those are also going to be congruent. And let's see, final piece, consecutive interior. Consecutive interior. That means you're looking at these two and these two. Okay? I understand that. I understand this has become very convoluted. This has become very messy. And I apologize for that. Hopefully the color coding has kind of helped you out a little bit. Otherwise, it's going to be very, very easy to be distracted, and I apologize for that. Remember, consecutive interior, those are going to be the only one where it is going to be supplements, not supplements, supplement. So they're going to add up to 180. That's going to be the only situation. The other three are congruent. Okay, but in that unique situation, that's going to be the one where it adds up to 180. So now, let's kind of flip this around. We got to see if we can kind of recognize the relationship that we have. So if you consider number 5, so if I look where they are, they're going to be on the interior, and they're going to both be on the same side. Okay, so that's going to be the consecutive interior. Okay, so remember, this is the one where a lot of students would write x equals 51, and that is incorrect. You want to take 180 minus 51, okay, and get 129 degrees because they are consecutive interior. Now for number 6, let's look at where they are. Okay, they're on the exterior. They're on outside the lines. Okay, and they're on opposite sides of the transversal. Okay, so that makes them alternate exterior. So they're alternate exterior, and I'll shorten that up down here. Alternate exterior, and they're going to be equal to each other. Okay, this is the only one where it adds up to 180. Everything else is going to be congruent here. So when I look, that's going to be 94 degrees by alternate exterior angles. Okay? So now, let's consider what we have here. Okay, so we are inside again, but we are on opposite sides. So that's going to be alternate interior. So those are going to be congruent. So you're going to have 2x plus 1 equals 105. So that's just an algebra problem. You've done many like this before. 2, so that becomes 0. This becomes 1. X becomes 52. So I can just say 52 because of, here I will say alternate interior. Okay, there we go. So now, sorry, I kind of jumped ahead there. So let's look a little bit more solving. So if we look here, number 8, I'm looking. You notice how they're both on the same side, okay, and they're both kind of below their respective lines. So those two, they're going to be equal. They're going to be congruent. This time it's because of corresponding. Okay, they are corresponding angles. So that means 3x minus 6 is going to be equal to 81. So add 6 to both sides. So that's going to be 87. So a little division by 3. Okay, and you're going to get 2, 9, 29. Okay? Okay. I would like you to hit pause and attempt number 9 before you watch me do it. So please hit pause and see what you can come up with. Just take a moment or two and see if you can at least get the initial setup and see if you can work it through to the end. Okay, let's see how you did. I really hope you recognize that as alternate interior. Okay, those are in alternate interior, and they're going to be equal to each other. So 8x minus 15 equals 5x plus 3. So if you got that, then congratulations, you're on the right path. Very good. So now it just becomes algebra. That is a 5. So that becomes 0. That becomes 0. 3x equals 18. X equals 6. Okay, last one. Hang in there. You're doing wonderful. So just because we have a parallelogram here doesn't mean that doesn't mean much. I just kind of have to imagine, like, if I kept this line going, okay, and I kept these two lines going, okay, I would have the same situation as previously. So now, as I look at this, what kind of situation do I have? I will take, if you had said in your mind consecutive interior, That's correct. That's correct. That's it. That's exactly what you want. Now remember, consecutive interior is the one that adds up to 180 degrees. So I want to take 5x plus 6 plus 12x plus 4 and set that equal to 180. So what does that become? That becomes 17x plus 10 equals 180. So subtract 10 both sides, whatever. So that becomes 10. X equals 10. Okay, now play around with this. Okay, these are ideas that you do need to be pretty stout with. You have to have a pretty good understanding of what you're doing. So I look forward to answering your questions about this. Thank you.